Okay, so this is topic 8, kind of a building upon what we had talked about in topic 7, where we talked about network security. This is a little bit more specifically, data in transit security. So, specifically focusing on things like SSL and TLS and IPsec, which are really the two major pieces of data in transit security. So, we talked a little bit in under topic 7 about, each layer has, potentially their security issues, security concerns that need to be addressed at each layer within the stack. So obviously, application layer, transport layer, network layer, data link layer. Each layer in a network stack has its own set of concerns that have to be understood and dealt with. All right. So, so say for example, the transport layer we're talking about, we want to protect data in a single communication session between two hosts. You don't want to have uh, man in the middle attacks, things of that nature, compromising information that could be captured and used as a replay attack. So each one of these things is something that needs to be kind of thought of and dealt with. All right. So this is some overhead here. So this is some of the descriptions around SSL and what we call SSL TLS and HTTPS. So these are some, there's a lot of information about this, and it's a fairly complicated topic. All right, but so what we're going to talk about is fairly, I'm going to keep this at a reasonably high level here in talking around these concepts. So SSL. So the original thought of where SSL came from is a lot of stuff. If we've talked about the internet, there was not a lot of security on the internet. All right, but what happened was when the internet was opened and people started using it for commercial traffic, there was a lot of obviously uh, concerns around. For example, if I putting sensitive information like credit card numbers and trying to run credit card transactions across the internet. Kind of difficult because basically, by default, everything gets passed across in clear text. So anybody with Wireshark could just simply go and read, monitor traffic as it comes across. So this idea of there was a need for that. So the original idea of what we call SSL, secure socket layer, was designed around this idea from an e-commerce perspective. It was originally designed by Netscape, which was the folks who created the first commercial browser, and then ultimately became a standard. And what it does is it implements a socket interface between the client and the server. All right, and then what will happen is a application can run on top of that. And I said this, it really is designed specifically to prevent eavesdropping and man-in-the-middle attacks. It uses a X509 certificate. You can actually do, it can be designed for one way, or it can also be designed as a dual certificate. And really, what it does is provides encryption and authentication on the server side. So it goes through a protocol, do a handshake, where when you first communicate, it'll request HTTP connection, pass along information. It will then respond back with information dealing with the keys and the type of encryption that is going to be occurring, and then dealing with also understanding what the certificate is. So it's a conversation going. An SSL involves, the establishment of an SSL session is a series of communications back and forth between the client and the server. As we see, basically both sides will do will send communications back and forth, and then at the end, it will, ultimately both parties, as part of this negotiation, will agree to how it will handle communication and basically being able to communicate, be able to decrypt traffic as it was passed back and forth between the two parties. Just a kind of a pictorial version of it, you know, initial request with a response, a key exchange, cipher negotiation, and at that point, then you've got, at this point, once both parties have agreed to how the communication will be handled, and the traffic the traffic translation established. Then what will happen is you'll send this message back and forth. So it'll do. This is some of the specifics around it, around different suites and different things. But basically, what you want to remember is around kind of this whole idea of the dialogue between a client and a server, and the types of some of the traffic. It's so what's part of that negotiation process. The problem you run into, there's a couple things within SSL. So it's not necessarily trivial to set up. So you have to define to set up certificates. You have to set up, it's fairly fair amount of overhead with resources. You know, questions about, there's been questions around, okay, is it really um, as secure as it would need to be? Do you see the lock icon, and do you really check the URL? The other thing that was known about this was that it was discovered that there was a particular version of this, which was actually a vulnerability was discovered within it. Um, so what's actually happened is SSL up to a certain point is considered not secure, the improper use of it. So subsequently, what you had was something called TLS. Right? So ultimately, there was a fix to SSL. I think it was an SSL. I forget the precise version. I think it would have been SSL 3. But when the patch came out for SSL 3, basically they also renamed it. So now SSL and TLS are kind of the same thing. TLS 1.0 is the same thing as SSL 3.1, and it has some additional security complexity, some additional stuff that's been in from different fields, you know, in some of the algorithms. So it's an enhanced. Think of TLS as an enhanced SSL. So this is basically kind of how this stuff has evolved right now. So basically, this is one of the main means of communication for security. Especially with commercial transactions. You see working with HTTPS, which is the secured HTTP communication, which is port 443. So the idea is that more and more the de facto mode of communication between on the internet is through TLS and through a secured connection as opposed to a non-secured connection. So some of the specific details of the TLS, some of the issues that have come up within it, and kind of how it will, kind of what the part of the negotiation for how the keys and the encryption will be established and executed during the communication. Also, some of the additional features. Some of the stuff was as I said, TLS should be considered an improvement and enhancement on SSL. So this is some of the stuff that was added to it, to provide higher levels of security and encryption, and also the security, security services. So basically what you've got within this around shared secret, which is around key negotiations, confidentiality, integrity, authentication, and then anti-replay. All right. So integrity using things like a sequence number as a means by which you can kind of subvert a replay attack. And this is some of the negotiations. Remember, as we talk about shared keys, key management and shared keys are a big part of network communication. So there's two different mechanisms. The RSA and the Diffie-Hellman are two different modes of doing negotiations. Basically, shared secret negotiations under TLS. Both of them are designed specifically to deal with things like man-in-the-middle attack. And it also has the ability to use a MAC key, basically taking the MAC address and turning that into a key as well. So there's some additional new features that are kind of baked into this, which adds additional security for your communication. Key management, as we've indicated, the idea is server private key security is critical for TLS security. You want to make sure that is your private key, the management of the private key, the execution of the private key is maintained to the highest level possible. So that was TLS. So the other part, the other major, so TLS, SSL TLS is the first big piece of this. The other major piece is something we call IPsec. All right. So this is actually security. It's the network layered solution for internet protocols. We're talking about TCP/IP. So this is the plumbing piece. It's baked into IPv6. It's used separately with IPv4. Right, so there's some the specific mechanics of it uses something called an authentication header, authentication AH, and they also call it encapsulated security. It can also be used. There's two separate modes. You can transport it or use it as a tunnel as well. So this is baked in. So this is IPsec is the baked-in security for IP. So the goal and the objective in this stuff is all packets should be authenticated and encrypted. Um, so in transport mode, basically you add headers to you add headers to IP, and it includes encryption and authentication. Tunnel mode uses IPsec between two gateways to relay the IP packets through an untrusted network. So there's two different ways. One was going to be basically you pack it onto you add headers onto the packet you're sending out, or the other one is you establish a tunnel and then relay the IP packets through the tunnel. Both are supported functions. So the idea is you do tunneling. It's between two endpoints. You basically you establish the communication is between like firewall to firewall, and then what you do is you can or to endpoints actually, tunnel endpoints, and then you strip off, and it'll actually take the security stuff off, and then it'll just simply it'll kind of repackage it, and then send the original packet as part of a payload that is sent to the other side. So in other words, you kind of create a package for it, ship it down the wire, and then it becomes, after it gets to its location, it then just simply gets turned back into a regular packet. So AH is kind of what we call around this, authentication is the mode. Add the header with authentication data onto the packet. Think of that in its simplest form. So IPv6 is, this is part of, and this is actually designed as part of IPv6. You can apply for IPv4, but this is the mechanism for it that has been baked into the IPv6 design. So as I said, you can piggyback AH into IPv4, so you can use it in IPv4 as well. ESP, basically, you encapsulate the datagram. What you'll do is basically you encapsulate your payload. In this case, so the difference between an AH and an ESP. AH, basically, you're adding a header. You're adding an encrypted header onto creating a package and then sending it along the line. ESP, you basically take instead of adding a header, you encrypt the datagram. You encrypt the content. Key management, once again, very challenging, one of the critical components on it. Use something called session keys, all right, and then also uses something called a Internet Security Association Key Management Protocol, all right, ISAKMP, ISAKMP. Basically, what it does is it establishes the session keys. It verifies that both parties are who they are, and establishes the session key and passes it along. A VPN, IPsec VPNs, basically allows you to basically create a private network running over um, the internet. All right. The ESP does the encryption. It requires two VPN gateways making tunnels between two trusted networks. And you see a lot of this. So this is a very common. So you see a lot of this uh, tunnel, VPN tunnel, especially now with the way network and basically with pretty much universal access with the internet is most organizations will just simply create connect to their local ISP and then use the internet and use basically the IPsec VPN as the means by which to create a secure communication between two host systems using the internet being able to leverage the internet to do it. So a little bit of a comparison between a VPN and SSL IPsec. So there are SSL VPNs and there's IPsec VPNs. There's two different ways um, to do a VPN. So you've actually seen more and more. IPsec was used pretty extensively. Now it really is more of a kind of a high level firewall to firewall, whereas like desktop VPNs, like people connecting in, you see more and more of this SSL VPN as the mechanism. But both are valid, both are used and used pretty extensively. And that is it for topic 8.